All right. I'm going to talk about threads in Java today. This video will give you a very simple explanation of how threads work, and future videos will go into more depth. So let's look at threads first. You have in a Java program that's typically one process, okay? In the operating system, that's typically one process, okay? Now, within this one process, you usually have a sequential execution of instructions. So for example, here in this listing, we have a class called raise. There's a main method that does not need to throw anything. Now I'm going to do a for loop for I equals 0 to 10. I'm going to print an enemy move and a hero move. So this is, imagine a race between the enemy and the hero, right? And they're all making their moves. So I'm going to compile this and then run this. And as expected, it will basically run here, right? So enemy move 0, hero move 0, enemy 1, hero 1, enemy 2, hero 2, and all the way to 9. Now, this will be sequential. However, if I want my hero move, for example, if I want the enemy move to be an automatic character in my game, and the hero move a character that I control, well, every time that I want the enemy to move, I have to wait for the hero to move. I'll have to wait for me to make my move, and then the enemy can move. Can you imagine a soccer game, soccer video game, or a sports video game where every player in the game has to wait until you make your move so they all can make the move, right? That would be pretty dull and not very realistic. And there has to be a way for me to be able to move my player and decide what to do with my hero in this case, while the enemies can move autonomously. Well, that can be done through threads. So as I was saying before, in Java, we have one process, which is typically my program is one process, typically not always. Now, in my program, when I run it, I can, when I run it, I have a space of memory where my program runs. However, in my program, I can spun what's called threads. Here, 3 threads, right? And these are basically tasks that I will perform that are executed in a way that looks simultaneous. Like if this thread is executing, at some point the system's going to say, hey, stop that thread, I'm going to execute a little bit of this task, and then I'm going to execute a little bit of this task, and then I'm going to go back to here, and then back to here, and back to here. So the program is going to be polling in a round robin. That's what you call it when you go from this to this to this, back to this to this to this. In a round robin form, I will be pulling threads or little tasks that my program is allowed to do. Now, this can be done in this way of polling. Let's look at how it's done then. So here's my program, right? Where the enemy move and the hero move, and it's sequential. Well, let's do the following. I want to automate the enemy move. So in order to automate the enemy move, I will use the thread class. Okay, so I can do new thread, open parentheses, and this syntax is lambda expressions, and it has to do with things that are going to go inside here that I'm not going to explain today. This is not the video for that, but I will put open, close, and then the arrow, and then I will put some code in here. I will close the parentheses of the thread and my semicolon. Now, what this is saying, basically what the thread does is it implements an interface with a method where you put your little task. This syntax is a little bit of sugarcoating that and saying, hey, I'm going to implement that little method right here. So this method, right, this thread here, I'm going to do for int I equals 0, I is less than 10, I plus plus, and then I'm going to put here system, well, I'm just going to copy this line. So this is the enemy process, whatever the enemy is doing, right? Just going to copy that and put it there, okay? In the meantime, my main program is going to count to 10 doing hero moves. Now, I've created a new thread here, but I haven't said to the thread, hey, go execute simultaneously. In order to do that, I had to put a dot and then start. So let's compile this program and let's see it running. All right, so if we run this program, we're going to have here, for example, we have enemy move 0, then enemy moved again. Then the processor gave some time for the hero loop, then the enemy move, then the hero loop, and then all the enemies that were missing, right? This is, for example, one execution where you have a thread. This was executing at the same time as this one, not sequentially, in parallel, if you will, okay? Or it gives the impression that they're executed in parallel. This is being executed at its own pace, this is being executed at its own pace. And if we run it again, we don't guarantee the same order, right? In this case here, we have enemy, hero, enemy, hero, enemy, hero, and so on and so forth. Oh, here we have enemy twice, right? And then the hero moves, and then at the end we have the hero moving twice. So this has to do with how the system scheduled the different tasks, right? But the underlying premise here is that this is done somewhat in parallel, somewhat at the same time. So if you were to have a complicated task here with a hero move where you need user input to move, or what is your next move or whatever, that doesn't impede this guy, the enemy, from still doing its own move, or the second task. So to recap, we have two tasks here. One that's part of my main method, and one that is part of a new thread, okay? By having it part of the new thread and calling start, I'm gonna make sure that this task is executed independently of this other task. And that is the first introduction to threads.